Okay, college algebra. We are in section R.8, which is the last section of the chapter. So we're getting ready to wrap the chapter up. We probably won't get all through this notes today. Like, there's a lot of examples. Lots. 12 examples, but some of them have like A, B, C, D, F, all the things. Okay, so we'll get through a little bit of this today. But section R.8 is all about rational expressions. Okay, so just kind of leading up to this point, we've been dealing a lot with polynomials, right? And those have been like, I don't know, x and x squared and x cubed, and we were combining like terms and doing all the things, and then we kind of switched to rational expressions. Okay, and that was stuff that was like x squared minus 4 over x plus 2, and we were reducing and doing the things, right? Because we had, you know, a numerator and a denominator. Those are rational expressions. I'm trying to think what else we had before that. That was mainly last section. Polynomials were mostly before that, and factoring polynomials. Yeah, so those are the two main things I guess we've done so far. And now we are on the last section, which is not rational expressions. These are radical. That's a typo. These are radical expressions. There we go. All right, so radical expressions, square roots, cubic roots, fourth roots, things like that, okay? One thing to note is that when you have a square root, I think we've talked about this already before, like if I have the square root of x and I want to write that as an exponent, that is x to the 1/2 power, okay? If I have like the cubic root of x, that's x to the 1/3 power, okay? Let's say if I have like the fourth root of x cubed, right? Okay, the root is the bottom of your fraction, and the exponent's your top. So that would be like x to the 3/4 power. Okay, now x to the 3/4 power can also be written as the fourth root of x, and that whole thing to the third power. So it doesn't matter if you do the third power on the inside or on the outside, that's going to still be x to the 3/4 power. Okay, and that's what they kind of have going on right here. So they say if you have a fractional exponent, it doesn't matter if you do the root first and then the exponent, or the exponent first and then the root. Okay, that's what they're saying there. Okay, all right, let's go down and do some examples here. Write each root using exponents and evaluate. So this is the square, or the fourth root of 16. So that's saying, what do you take, that's 16 to the 1/4 power, if they want it to using exponents. But the fourth root of 16 says, what do you take times itself 4 times to get 16? And that is 2. And so 2 is the final answer. Okay, B, we're just going to deal with this guy right here, which we know just came out as 2, right? Like that value is 2. I shouldn't put an X there. This is 2, and then I attach the negative there, so that is -2. Okay, the negative is just chilling out in front until we attach it to this. Okay, now this guy is saying the fifth root of -32. I didn't think you could take roots of negative numbers, but you can as long as it's not an even root. Okay, the fifth root of 32 is saying, what can you take times itself 5 times to get a -32? Okay, this would be -32 to the 1/5 power if we write it as an as a power. But the answer is going to be -2. Okay, because I can take -2 times itself 5 times, and a negative 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 is going to keep it as a negative, right? 5 negatives make it stay a negative. Now, when we hop down here, let's just do F next, since I'm already on this side. When we're talking about a fourth root of a negative, there's nothing that I can take times itself 4 times to make a negative, right? 4 negatives is going to make a positive. So that's not going to work. 5 negatives will keep it a negative, but 4 negatives won't work. So the fourth root of 16, we know that that's 2, but since we have a negative in there, it is going to be an imaginary number. So 2i is what we will have for that one, okay? Because you cannot take an even-powered root of a negative number, okay? Can't take even roots of negative numbers. Okay, that's just the general rule. Okay, let's go let's go back over to D. So this is saying, what do you take? Oh, this is 1,000. I'm not doing a very good job of doing this power thing. 1,000 to the 1/3 power, that's what the third root means. And this means, what do you take times itself 3 times to get 1,000? And that would be 10, right? 10 times 10 times 10 is 1,000. So the correct answer there for D is 10. This one is saying, what do you take times itself 6 times to get 64 over 729? Okay, and what we can do there is we just do those 6th roots separately, right? It's like taking, oh, why did I put 74? I don't know. Are you yelling at me yet? 64, okay? So I just do those roots separately. The 6th root of 64, I think is it 2? Yes, it is 2. 2. And the 6th root of 729 is that 3. It is 3. Because 3 times 3 is 9, and 3 times 3 is 9, and 3 times 3 is 9, and 9 times 9 is 81, and 81 times 9 is 729. Yes, so 2/3. Don't write this crap down. That was just my thought process because I don't have a calculator in front of me. But 2/3 is what he will be because you do the 6th root individually. Okay, so that was that mess. Boo. Example 1, done. Okay, just remember that if you have an even-powered root, you cannot take a negative of an even-powered root. Or you cannot take an even root of a negative number. Whatever, you know what I meant. All right, here we go. Example 2. Write in radical form and evaluate if possible. Assume that all variable expressions represent positive real numbers, okay? So this is 8 to the 2/3 power. Remember that the bottom number represents the root, okay? So I'm going to do the cubic root of 8. Now, I can decide whether I'm going to square that first or whether I'm going to square it last. I am going to, in this case, square it last because the cubic root of 8 is a nice number. That is just 2, and 2 squared is 4, okay? So that's how I kind of arrive at that conclusion. Otherwise, I would end up taking 8 squared, which is 64, and then I take the cubic root of 64. And I don't really, I have to think about it if I'm taking the cubic root of 64. It is 4, but I know that the cubic root of 8 really quick is 2. So I just go that route instead of, squaring the 8 first, okay? And you can choose whichever one you want to, all right? Here we go. Let's do B. This is the 5 is the 5th root of negative 32, and I'm going to do the 4th power last, just kind of like I did the 8, okay? The 5th root of negative 32, I think we did that one above, is negative 2, okay? Now, the negative 2 is to the 4th power. Okay, so 2 to the 4th power is 16, but I have to decide, is that a positive 16 or a negative 16? So if I look back at the original, the negative is inside of the parentheses, which means I am taking the negative to the 4th power also, and a negative times a negative times a negative times a negative is going to be a positive 16, okay? So that's how that works out, okay? C, this negative is on the outside, so we're going to just separate the negative and the 16. I'm going to just deal with 16, the cubic root of 16, that number to the 4th power. And again, I could do the 4th power of the 16 first, but 16 to the 4th power is going to be a huge number, okay? So I'm going to do, I did not do that right. Are you yelling at me again? The 4th root of 16 is what I'm going to do first, and that cubed, okay? I could take 16 and cube it first, but that's going to be a huge number, okay? I know that the 4th root of 16 is 2, and 2 to the 3rd power is 8. Now I attach the negative onto it, okay? The only thing I was taking to the 3/4 power was the 16, and that was this guy, so the negative was chilling out in front. So negative 8 is the answer to that, okay? All right, E. Oh, my. Okay. This is to the 2/3 power. Now, note that this does not say 3x to the 2/3 power. If it would say that, we are assuming that the 3 goes underneath of the cubic root. Like, this is how I would treat that, okay? But when x is to the 2/3 power, the x is the only thing that I have to that power. So the 3 is just chilling out front. Then this guy says the cubic root, and I'm just going to say x squared underneath of that, and I'm going to call it good. Okay, we can't do any more simplifying than that because we don't know what x is, right? You could write it like the cubic root of x squared like this, but if I'm going to leave it, I a lot of times will leave the x or the exponent on the inside of the radical. Okay, that'll make it a little bit nicer. All right, f, again, the only thing that's to the 1/2 power is the p. So this is going to be the square root of p. The 2's chilling out front. If they wanted the 2 to be underneath of the square root, they would have written it like this, right? That means the 2 is also underneath of there, okay? So this is the final answer right there. G, everything, like this one is in parentheses, everything is to the 1/4 power or the 4th root. 3a plus b. And there's no other breaking down that you can do from there. That is all, okay? These bottom 3 were ones that we couldn't, oh gosh, I forgot D over there. Those bottom ones were ones that we cannot simplify, okay? All right, D over here that I forgot is the 6th root of x to the 5th power. That's how I would write it. You're not wrong if you write it as the 6th root of x to the 5th power. Sometimes they'll write it like that, okay? So either way it works. I don't know that you even have to have the parentheses outside of there, but this looks kind of weird. It looks like my 5 is just floating around, somewhere crazy weird. And that's kind of why I read him. I prefer writing him like this. So whatever. That was example 2. Let's do a couple more and then we will stop, okay? Write in exponential form, assume all variables represent, blah, 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 all the good stuff. Okay. The 4 is the bottom of your exponent, so this would be x to the 5/4 power, okay? The 4 goes on the bottom, all right? That was A. B, this whole thing, they want the 3 and the y to be underneath, so I'm going to make sure that this 3y is in parentheses, and the square root means to the 1/2 power. So that's what he will be written like. Not just the y to the 1/2 power. The 3 is also included in that. So we do parentheses for that. Okay. C, the only thing that I have here is the z. The 10's just chilling. So I want that written as an exponent, right? Okay. So this is z to the 2 is my power and 5 is my root. So to the 2/5 power. And he looks like that. Okay. The 10's just chilling out front. He is not also to the 2/5 power. Otherwise, we would write it like this, right? But z is the only thing to the 2/5 power, okay? Let's go down here. Here, the 5 is outside, but the 2 is underneath. Oh, heavens. Okay, let's do some thinking here. I'm going to do this. Since I have a 4 here and a 7 here and a root here and all the things, I'm going to do this. I'm going to distribute the 7 through to those 2 pieces. So this is now 2 to the 7th and x to the 28th power. Okay. All right. Yeah, okay. Now I'm going to... Yeah, they just want them written with the exponential form. Okay, whatever. Now, this is what this means. 2 to the 7th and x to the 28th. That is now all to the 1/3 power, right? And so what I can do is I can distribute that through, right? We weren't used to writing it like this, that way. But like this, we kind of skipped steps. So let me talk about this real quick, okay? This means x to the 5th and then to the 1/4 power, right? Like the 1/4 power is on the outside. All I did was I kind of skipped steps and I went and I multiplied 5 times 1/4, which is 5/4, okay? Same thing here with B. Well, that one didn't have an exponent there, so I can't really say that for B. C, yeah, C. This is z squared and then to the 1/5 power, right? And so I just skipped steps and I made that 2/5 right away. Okay, so what we can do here, down here as D is I'm going to write that to the 1/3 power and then I'm going to distribute that through for these guys. So 5 still just chilling. This is 2 to the 7/3 x to the 28/3. Okay, what a danged old mess. And we're just going to leave it like that. Yeah, they might have wanted you instead to just leave this 7 chilling out here. And what we could have done is write that as 5 to x to the 4th and then made that the 7/3 power, right? Like just do the 7/3 or whatever, But that's the same thing. If we would distribute it through, then that would be the 7/3 and the 28/3. So I'm not sure how they want you to write it. I'll take either one, I guess. So if you read it like this, or if you read it like that, whichever one makes the most sense to you. Okay. All it said was write in exponential form. They're both exponents, so I don't see what the problem is. Okay. All right. E. We're getting into like some detailed stuff here. All right. E. This whole thing is to the square root. So this is p squared plus q, all to the 1/2 power. Okay. And that is all. Now, here I can't actually distribute this through, this 1/2 through, because the plus sign makes him trapped, okay? I am allowed to do that here with the 7/3. I can distribute it through because this is 2 times x, okay? So there's a difference between multiply and add. If you have an addition, then those things are trapped together, and I cannot distribute that 1/2 through. So I have to just leave it as this right here, okay? And that is all for that example. Let's see. I'm just going to do this top part right here. These first 4, and then we'll save the other 4 for tomorrow, I think. How much do we have left? Oh, we still have a lot left. Okay, but anyway, we'll just do these top 4, and then we'll save the bottom 4 for tomorrow, okay? So square root, this one is saying the square root of k squared. And what happens is a square root and a square cancel each other off, and so this is just k. It's basically saying, what do I take times itself to get k squared? That's just k, right? Here, the cubic root of k cubed, the cubic root and the cube cancel each other off, so that is just k. This is saying, what do you take times itself 3 times to get k cubed? And that is just going to be k, okay? Here, we have the square root of p to the 4th power. So this is saying, what do you take times itself to get p to the 4th power, okay? Another way that you can think of this is that this is a square root, okay? And the square root we know means to the 1/2 power. Well, what happens if I take these 2 and I multiply them together? I combine those. That's just p squared. What do you take when you, or what do you take times itself to get p to the 4th power? It's p squared, right? This is just another way of thinking about that, okay? And then D, what do you take times itself to get p to the 4th power? Excuse me, what do you take times itself 4 times to get p to the 4th power? That should just be p, right? Okay, but another way of thinking about that is p to the 4th. This root is to the 1/4 power, and 4 times 1/4 is just 1. So it's p to the 1st power, or just p. Okay, that's kind of how that works out. All right, actually, you know what? Yeah, let's do the bottom 4. Let's just do these bottom 4. Sorry, you're going to kill me. Let's do these bottom 4, because while we're on the same, like wavelength here, let's just do it. Okay, this, I have 3 pieces. And then we just do each piece separately. So with the square root of 16 comes out nicely. It is 4. The square root of m to the 8th power is m to the 4th power. Okay, another way of thinking about that is m to the 8th. And then the root means 1/2. 8 times 1/2 is 4. Or, in other words, you're just taking each one of these roots and you're dividing by 2. Okay, now, if you have a solid number in front, like a constant in front, you are actually taking the square root of 16. You're not dividing that 16 by 2 and making this 8, right? But if it's an exponent, you're dividing it by 2. So m to the 4th power. R to the 3rd power, you're taking 6 and you're dividing by 2, right? If this is r to the 6th and then to the 1/2 power, multiplying those, 1/2 of 6 is 3, okay? So that's how that works. That is E, okay? F now, a 6th root and a 6th power cancel each other off, so this is just -2, okay? G, a square root and a square cancel each other off, so this is just 2k plus 3, done. And then this last one, how the heck does this last one work? I'm tempted to do like the square root of x squared is just x, right? But the problem is he's trapped. X squared is trapped with the 4x and trapped with the 4. So here, let's do this. This guy right here is a simple trinomial. And when I break him down, multiply to get 4, add to get -4, that's going to be x minus 2 and x minus 2, which is the same thing as x minus 2 squared. And a square and a square root cancel each other off. So he is just x minus 2. How fancy. Okay? All right, so we'll stop there. That is all of the things, and that should get you through just a little bit of the homework assignment. We still probably have a couple more days left for for this section, but that should get you a little ways through. Okay,